Alright. Okay, hopefully you can hear me. Maybe you can't see me yet. I would try to fix this. Alright, I think almost everything that could have gone wrong has gone wrong. So hopefully we're good now. And we're ready to go. So, this is it. We're going to be streaming our project here I've been working on for a while now. It's called LambdaTrek. It's a roguelike type game inspired by the Star Trek universe and older games and variants that have been made since the days of yore. If this is your first time tuning in, welcome. It's nice to meet you. I'm the Agent Ultra. I'll be your host tonight. And yeah, this is what the game looks like so far. We're going to go over to my project in the LambdaTrek there. And we're using the stack build tool. Stack's a build tool for Haskell. We program Haskell on the stream. That's what I do. Yeah, it's pretty cool. And we run it like this. LambdaTrek. Bang, 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 bang. Cool. So this is LambdaTrek. All right, this is the main like sector screen that you see here. We've got our current sector, 0, 0, and all that stuff. I think we got a few things to fix here, because usually there's an S to show you where your ship is. And we've been updating and changing a whole bunch of stuff lately. I'm getting ready to do procedural generation. Because now we can warp to different sectors. This is like the quadrant map. You'll be able to warp to different places in here. So you got your command inputs. That's where you can move. Things happen. You got a dialogue area. You've got your info panel here. We're getting a game going. It's going. It's moving. It's happening. So there you go. Turn-based, terminal-based, at least for now. Maybe one day we'll port this to a graphical backend. That'd be pretty cool. But for now, we're using the brick library right in the terminal UI. It's just for quick prototyping, just for checking things out, seeing how it's going. You know, building stuff, learning things, having fun, hopefully. I'm having fun. It's a pretty fun little project. Okay, so this is our to-do file here. We're in the middle of refactoring a bunch of data structures around sectors and stuff in preparation for, again, all that procedural generation stuff we want to do. Let's see, warping. Yeah, we also needed to do the ship, the safe space for the ship. Got to put that in. And yeah, I mean, this whole sector stuff that I've been working on has been part of that as well. I think it started from doing that, trying to find a safe spot to put the ship when we warp to a new sector. Ah! Man, it has been a while. Gosh, I don't know if we should do like a reflection or something here. I feel like we've been doing this stream for a very, very, very long time. Some kind of milestones being hit here. Anywho, let's get down to business. We're going to LambdaTrek. We're going into. Let's fix the UI first, because we want to make sure that we can see the ship. Bam, 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 bam. Okay, is there UI code here? UI code is written with Brick. And Brick is a nice little declarative kind of language. Library, I should say. For making UIs. It's very nice. I like it. Let's see, our sector display here. Yeah. Oh, there we go. Handy dandy. To do. Add the ship back in. What? It's totally out of my mind how this ended up happening. So let's just uncomment the code and see what happens. That's not used. Okay. Good to know. Right. Sector rendering. We took the ship out of it. Didn't we? It's coming back to me slowly, folks. Alright. LambdaTrek. Simulation sector. Okay. Just takes the tiles. Renders it out to text. Okay, so if when we build the sector tiles, we're building that all from the sector data. And I think what we can do here, The one thing we wanted to have kind of happen with the sector data is that a certain invariant needs to be maintained in it. And that there's always a valid one empty space. One empty space, so we have at least one place to put the ship at all times. Right? It's even in there in the comments. Thank you, past me. And so, when we go to create the projection of the sector doesn't contain the ship. Like where to put the ship. Its current position. So I guess we have to kind of figure out where to put that ship. When we move the ship. We got to do a bunch of stuff with the moving of the ship. Okay. So let's look at how we construct our data at the moment when we start up the game. If we go to state, we kind of keep all of the state we need for the whole game in one big record, just everything. So we got our random generator here, we got our game screen, we've got turns, the ship data is here. And that variable is poorly named. I believe that's the current sector that the ship is in. And the ship itself has the position that the ship is in. Okay. And let's see, when we go to render the sector, all right, we look up that sector from this unit here into our quadrant data. All right, so this is like the index into the quadrant data. And let's pop over the quadrant data. Okay, so this is where we have the stars that we want to render, the enemy ships, the stations, even the scan state of the quadrants. That's for building the map. And let's see, we enter the quadrant with a starting coord. Yeah, and the starting coordinate is just used to initialize the quadrant scan state. Initialize that, okay. So we just set it to true if it's scanned or not. Okay, so my feeling is that we need to pass in the ship data into there. And the only thing is that, well, we know that we can always place a ship in there, but we may have to tell the ship where to be. When we want to go place it. Okay. So, I think that's over in shippity ship. No, it's still in sector. It's probably the right place, but cores, render, build sector tiles, find empty, find empty. Okay. So find empty is going to get our sector tiles, get the turn into an association map. We're going to filter the tile to be empty space. We're going to take the first one of that, its index, and they're going to map that index to a coordinate. We get it as int, of course. Okay, and find empty only works, of course, if our sector tiles data is appropriately built. Okay. So then I think we just need to implement maybe the ship placement stuff. All right, there's our function. It has at least one empty space that we use to check that. Okay, so we have find empty. That means we can simulation handle move. Engine move. Handle command, engine move. Handle engine move. Okay. So in handle engine move, we get the ship, we check if we collided with anything. If it's all missed, then we move it. And we say it was formed, otherwise we don't do anything. We say it was denied, we couldn't move. And then each of those individual collisions turn a collision result so that we can say different things based on that. Okay. That's all fine. Now let's go to the back to the sector. Let's add a place function. Yeah. Place ship. No, we have find empty. Let's see. Find empty. What would place ship do? So find it. We're gonna. Ugh, I'm getting lost here. Let's go to state. Okay, forget about is it in the right position. Let's just render the ship back in. No matter what, we're gonna have to put the ship in there to render it. Okay. So we get the sector tile data. Presumably the ship will only move to a safe position that it's allowed to move into. And so we just have to get the position of it. And render its tile. Now this should be like sector tiles, I think I'm going to rename that. And then maybe we could use the safe sector tiles function. Or maybe an unsafe one. That's the safe one. Let's just use unsafe one. We will get the ship's position. X, ship Y. Ba-ba. Do. And we'll do. Oh, we have get position, don't we? Okay. We'll sector unsafe set tile. We'll get ship X, ship Y, ship tile, something like that. And yeah, sector tiles is good. Player ship is the tile we want. Okay, ships in scope. We might end up creating a circular reference. Hopefully not by adding it here. Get our builder going. We'll use the test runner fast and the file watch. Okay, we have to import that qualified. And we'll probably have to fix that. Yeah, we'll just pop this over here, like this, get this, and we'll just get the pipe. There we go. Don't know if we need the constructor, but I'll just leave it in there just in case, because why not? Up over here, player ship, we need tile. Oh, it's in there. We just need all the constructors of time, so we're actually constructing one, I guess. Catch up with me here. Oh, we need this. We named the constructor the same. Okay, let's import tile qualified. That's why I had it like that. No. What was the problem here? Let's get our type errors going. Couldn't expect to match sector tiles with actual type array int int. Okay. Unsafe set tile. Takes a sector tiles. Okay. And get sector tiles. Returns the array int int. Okay. We'll move this around. And boom, boom. Shadows. Okay, that's not a problem. I'll just call it tiles. So this will be sector tile array. Super. And let's see here. I guess we don't need this one. That's probably fine there. Okay, let's get rid of that. Okay, do we compile yet? Not quite. Good, good. So let's go update our UI code now. We have to give it a ship now. Let's bring that back in scope. Okay, we're back to green. That's a good start. Okay, there's our ship again. Okay. That's back. That's good. Okay, so then we just need to... All we need to really do here is have a way to set the ship's position. And then when we handle warping, we use the find spot, put them in the right spot, and there we go. And yeah, and then I think we can move on. Knock a bunch of those to-do-offs. Phasers 100. Oof. We don't have that much energy, Captain. Let's fire phasers 30. Boom. Alright. Dock. Alright, replenished our supplies. Running down on turns, but we did it. Okay, cool. Let's do it. I'm going to leave myself a little to do here. Maybe not the best way to be placing the ship tile. I'm not sure. Okay, so let's move on to that. Let's commit that and then move on to the warp stuff. Oh, hi. I've got new friends on the stream. I don't know if they will show their faces. But the reason why I couldn't stream last week was because of these guys. A friend of mine, unfortunately, had to deal with a situation, a living situation issue. And in the middle of December, it sucks. But they couldn't take their cats. They found a place to stay, fortunately, but they couldn't take their cats. So we took them in. And now I have a bunch of other cats. A bunch. Yeah, don't walk on that. It's not good. No, thank you. This beefy boy. See? Oh, you knocked over everything. Oh, his cats are want to do. Sorry, stream. Hopefully you don't get to see my terrible non-studio. Okay, well, I'm back. Cats, man, I don't know what's up with that. Okay, they're just curious. He's a good fellow. All right, work in progress. We've got our add ship rendering back in. Oh, gone. So handling warp. We go to simulation, handle warp. Okay. So we got the ship there, we get the warp factor in the distance and energy consumed, the coordinates. We set the coordinate to the new one that we warp to. We If the energy is consumed is less than the energy we have, then we decrement the energy, scan the quadrant, say set the coordinate for that, and we perform it. Otherwise, no, this has a bug, of course. Game say we shouldn't set the coordinate until we actually warp. Okay, there we go. Okay, energy consumed. So it's in this branch here that we have to use our find safe tile and change the ship's position to that tile's position. A tile's coordinate. Okay, let's go to sector code. Boom, bow. Find. Pop, empty. Okay. So I need to get the quadrant here in order to do, or the sector tiles. So yeah, I need to get the current sector from the quadrant that we just moved to. Then we need to find the empty tile. Put the ship in. And then update the ship position to the empty tile position. And that's it. Okay. Let's see if I was helpful to my present self in the past by giving me a helper function to get the current sector. Get sector. I do. Okay. And that's the peer functions. We're gonna go let sector equal to quadrant.getSector, q.getSector. And we have to give that the quadrant. Let's see. Game state quadrant. And a coordinate, which is chord. Not in scope. It's going to be use game state quadrant. And that should do it. Thank you, GHC, for the help. Nice assist. Okay. We got the sector. Now we just have to find the empty tile. We know how to do that because we wrote that. Alright. Safe tile. Coordinate. And that should be... We gotta get the sector tiles. And from that, we can find empty. Or after doing that, we can do empty. Okay. And then we set the ship position to that coordinate. Has position. Yeah. Okay, so we'll move this code up here so we can use the zoom block for this. And there we go. Yep. position X. And we will set that to save tile X and save tile Y. It might be nicer to have if HasPosition had a function on it for setting the position of the positionable thing. That would probably be nicer, make this code a little better. Let's see. It doesn't like it when we do that. I'm just using the wrong one, maybe. Or is it more of this? Yeah. That's the one. Okay, we only really need that there. Let's just get rid of the binding, the shadow area. There we go. Okay, cool. We've got a couple of build warnings somewhere. I would like to clean those up. Oh, it's in this module. That's helpful. Get rid of those. Okay, cool. I like to build cleanly. No warnings, you know what I mean? Okay. Let's see now. Let's check our game out. Let's warp to 1-1. Okay, we move to warp 1-1. Okay. We warped in at the top corner. When you move into the sector, move it a little more. We warp to 2-2. And it's the top corner again. It's a safe tile. I'm gonna say that's good enough for now. We might want to add a little to-do there, though, just to randomize it up a little bit, you know. It doesn't feel nice always popping at the top left corner. It could be like, you know, pick one of the empty tiles. But right now we're taking the first one we find, which is always going to be the top left in this case. Because the way we wrote it. However, update handle warp. Ship will now be placed on the empty file in the sector. Now this is assuming, of course, that when we construct the ship, the sector data, and as we build it, manipulate it, that invariant will always hold. So we'll see. We'll see how that goes. All right. Actually, I can probably just reword that one. Abort, please. Yes. Oh, no. That one's fine. I'll just pick that one. I want to reword that one. There we go. That's good. Super. Okay, so now that we have kind of a game, we can get out of that initial sector finally. We can go zip around the universe and the quadrant. But we have to be within range that we can get to. Cool. Right, we can zip along the universe. We can long-range scan if we wanted to. Before we jump somewhere. That sort of thing. And then we can warp to 1-3 if we wanted to, and that'd be all good. But we don't have enough energy to make the jump, Captain. Oh no. We only have 2 energy left. I don't even know if we have enough to get over that space station. Ah, we don't. Game over. Ran out of energy. So now we need to spread the universe, the quadrant, full of stuff for us to interact with. We need to generate a bunch of enemy ships and stations and stars and put them in the different sectors. All right, and then we got to start the player off somewhere. Maybe give him a little blurb about what to do, and then yeah, you start the game. And then, who knows, from there, what we will do, where we will go. Okay, so, procedural generation time. So we have our random generator that we've been using for damage stuff and like battle combat stuff. We probably should reuse that generator and keep using it for world generation when we set up the game. So what we need, instead of init quadrant, we need a generate quadrant. I think we could probably even put it past in that generator there. Something like this. We will put the next state of Gen Prime as generate quadrant. And that'll be in. Pow, 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 pow. You know what? I'm gonna move that back all over. Oh, move back up here. That way, put you there, and then it's not quite so far over. Okay. The generate quadrant is going to take care of generating our stuff. We're going to pop gen in there as a parameter to it. Right. And then in order to finish initializing the game state, we would have to initialize the ship as well. We'll get to that, I guess, in a separate step. Because as long as we know that as long as our sector stuff holds when we generate the quadrant, there'll be a safe place to put the ship. So we just have to pick a sector to start in and all that stuff. So let's hop over to my little to-do file. I don't think we've done the setters yet. We'll probably get into that as we go along here. We did that though. I'm not sure if we did that, so we'll leave that there. And to quadrant generation. Let's see, so we need a generate quadrant. And we need to generate player ship. And then we need to set the rest of the initial quadrant state. I'll just put a catch-all there. Generate remaining stuff. Okay. That's the gist of my project management style right there. Just write something down, forget what it means later, and just start again. Now, usually I'm a little bit smarter than that, but sometimes it's how it is. Okay, so let's go to generate quadrant. I'm gonna go source, LambdaTrek, simulation. I'm gonna start a little quadrant and I'll generate.hs. LambdaTrek, simulation, quadrant, and generate. Okay. What was that? What the type should be? Let's let JHC tell us. Okay, so I think our builder is going to get a little confused by this. Or no, it hasn't been imported yet, so maybe it won't be. There we go. We need to import system.random here. It's going to be a stud gen. And we're going to return a quadrant. Hopefully that doesn't form any cycles. I think that should be fine. Yep. Okay. Let's begin. Okay, so let's look at our quadrant data structure. Okay, so we have these maps that we need to fill in with a bunch of data. Now the maps are, the coordinates are fixed. They're kind of a fixed size thing. We don't really need an unbounded map here. It's just easier. It's kind of just an implementation detail. It really, I don't know. It's not really an unbounded map. Okay, that's enough. That's enough. Yeah. Okay. As we saw in the game, I think we're only, what, 4 by 4, right? So 0, 1, 2, 3, 0, 1, 2, 3. Okay. So for each of those, we need to generate stars, enemy ships, stations. The scan state's going to be fixed. All right, and we can initialize the scan state. Oh, maybe we should add that to the 2. Well, that really gets... Yeah, I think we need to do that as well. Set initial scan state. So that's like where the current wherever we decide to place the player ship. That might even be part of generate player ship. I don't know how that'll shake out, but we'll put a reminder there for us. So yeah. So I think what we're gonna do is go through those one by one. In fact, how do we want to structure this? Maybe we can just do this line by line. We could do generated stars. And that could be generate quadrant stars. Gen. And we can generate enemy ships. And we can make that generate enemy ships. And we can generated stations. If I could type today, that would be great. Yeah, supposing we could do all of this, we can then I think the easiest way to do is to borrow our quadrant constructor. And override those particular fields. Just because that already sets up the scan state. And we're going to hard code that for now until we can actually set it after like choosing a place for the player to doing that step. So that's what I'm going to do. Init quadrant. I think we do hard code this to 0, for now, and we're going to just override a couple of those places. So the quadrant stars will be generate stars, and the quadrant enemy ships will be the generated enemy ships, and the quadrant scan stations will be the generated stations. Okay, that kind of look like that. Okay, so let's implement those. Generate quadrant stars. That's going to be a standard generator. Quadrant to map int so a list of tuple of int. Now if we use the standard generator, the pure one, normally we have to take the result of those functions out, since we're using a pure one, and pass that on to the next thing, because it's it's not we're not running in a monad here. It's not impure code. It's not being there's not a reference being held somewhere that subsequent actions can use. And that's because when you sample like a standard generator like this, it's going to change. It's going to produce a new state, and you use the new state to pass into your next sample function, right? And that's how like a lot of standard generators work under the hood. We're not, and the reason why you want to do that is so like the next number is also random, the next number after that's like random. If we sample all of these without doing that, they're going to all sample from the same initial state of the standard generator, which could be fine. Because once the gameplay starts, I think all of the gameplay that does use that for the combat and stuff handles setting the standard generator back into the game state and stuff. Oh, but it's going to pick the same... It might end up picking the same positions for the stars and the ships and the stations and all of that if we do it this way. So we probably should be passing those back into the game state, or passing those, returning the final standard generator. Yeah. So this really... Yeah, let gen prime here. Yeah. This should be gen prime and a quadrant. Then this can be a quadrant. There we go. All right, and here we go. All right, it's almost like a state running function. Composing these together. We might end up running it in a state monad just to make writing these functions a little less annoying. So each of these is going to return now a stunted gen. Right, and this one's going to be gen prime. And this is going to be gen prime prime. And that's going to take gen prime. And this is going to be our final state of the generator once we're done with it. And then we have to return gen prime prime prime. Kind of ugly. I'm gonna pull that up there. Yeah. Not a huge fan of that. And so we can probably make that go. Generation state. Generator random gen. All we need. Let's just make it a new type. And then we can create our generator. New type, quadrant generator. This one's mostly going to be like a pure one. Although we're going to need that, and then we're going to get quadrant generator. I know we don't need to define our own. We could just use state directly here is fine. State and generation state, and we're going to turn the quadrant. And we'll import full dot state. Okay, then we can get rid of that. And then we should be able to get rid of these. In fact, that one, that one, and that one. We can get rid of the let binding altogether. Move back over this way. Turn this into a do. Happy little do, and these become binds. And then they don't have to take gen in. It'll be threaded through the state. This becomes a let bindings. It's still kind of it's still a pure expression. And then we can return just quadrant there. Okay. So then our calling code and the initiate here is what's gonna call we got control.monad state there. So we're gonna call we're gonna evaluate this just for the result. We're not gonna keep the state through. So I believe that's is it run state? Is it exec state? Exec state. They're all kind of somewhat backwards. And in that they take the state as the third argument instead of the state function you want to run. And so we're going to need generation state here. With our gen. No, we want the final generator returned, yeah. So we'll use whatever one that ends up being. Something like that. It's not right exactly, but let's see. Let's go to quadrant generator. Now we need that anyway here. Okay, so this can become state, generation state, and we're going to return that map. Okay, we're going to generate quadrant. Generate enemy ships. That's going to be very, very similar. Except this. Need an array, I believe. Of enemy. Right, and then station is going to be very, very similar to that. Stations. We need to add those, yeah. And here. There we go. And then we need data.array. Yeah, it's not enemy stations. Stations. Oh, and what is this one? Yeah, just gonna put some parentheses around that, just because we're using the regular update syntax, and I was just getting a little confused there. Okay, and then, yeah, so it's, oh, it wasn't, I think it's eval state is the one we want, where we return thing. We're going to want generation state. Just get generation state back out. Go. No, it's not eval. Run state. What is it? Exec. Let me look at my documentation. Sometimes I get these messed up. There's three of them. Run state is the one we want. That returns the tuple. Okay. Why was it chirping at me when I was using run state here? Oh, because the state's the second part of the tuple, not the first. Okay. Quadrants. Okay, gen prime's gonna be used down here. And then just clean up here. We don't need that. Okay. Oh, we don't need it. Let's pull this over to the left. It's getting a little unreadable. Okay, okay. That's our initial game state. That's going to be our setup for our generator. We got it in place. Okay, so now we can focus on the individual parts. All right, this is not gonna be the most. I don't know if this is gonna be the most like brilliant way of doing this, to be honest. It would be nice if we. Well, let's do the easiest ways. Like, we don't have a ton of requirements here, space planning level planning wise. But I think we can get by with just like a speckling, a light random distribution of numbers, as long as they're within range. It might be that, like, once we generate a few quadrants, we see that, like, the distribution doesn't look very nice, and then we might want to do something about that. So, like, stars are, you know, spaced out, so to speak, appropriately, which means just like a different distribution. We'll have to kind of play around with that, tweak it, I guess. So for the first part, let's break it down into pieces. So we have to go for each coordinate in our map in order to generate it. So ultimately, we're going to be generating from a map from list. And let's import data.map.strict. Qualify that as map. Yeah, I know it's empty for now, but it won't be for long, GHC, don't worry. Okay, so in this list, we're going to have to put our coordinates. It'll be tuples, because the coordinates are going to be our key, and something there, where almost the same expression actually as what we have already in the quadrant constructor. That was comprehension. Yeah, exactly this. The difference is going to be that we're going to replace a part of this with another random generator. Let's see. We want to almost have like a statefully generate this miscomprehension. Oh, was what I want to be able to do. We could probably, I don't know, maybe we could put a function here, like vector stars. Almost. I wonder if we could do like a traverse with this, maybe. And traverse our stateful generator over it. Maybe it's traverse or is it sequence? One of the two. Barrel. So let's see, applicative F. So a function, each element that we're traversing over, FB, returning an F in a sequence of T to B. So that's like an action, and I think our state T should fit the bill for F. Which means quadrant coords. This will be like quadrant coordinates. We already have quadrant coordinates. Okay. So we'll traverse over that. I don't know if we're going to need to do. We're going to traverse over that, our function. Right, it's going to be like, it's going to get a coordinate, and we're going to have some other state generating function here. So we're going to generate sector stars for that C over quadrant coordinates. Right, and then that returns us state T action. So we're going to bind that to get our so we have to turn it into a map. Well, I think maybe we could do it like this, from list. And maybe there's a way for map, we could shorten that up, where we could just put the map, some map constructor over that thing, but no, that should be fine. So let's try implementing and generate sector stars. All right, this hole should be of type, yeah, T int to state and generation state. And then this will be a list of int and list of right. This. Wasn't quite what I was thinking. What are we doing here? We only have to generate one. I got the type wrong on this. Yeah, we only have to draw. Okay, yeah, we only have to generate one tuple for. This is for each action. Okay, cool. Awesome. Oh, it's int to state, generation state. And we just have to do int to list of int. Very, very descriptive type signature. Okay. Wonderful. Okay, so we know right off the bat here that this input int is our coordinate, and it's going to be it's going to be the key as well. It's going to be that one. And so we're going to turn a coordinate and something else. Okay, now something else is our list. Okay, so let's see. What do we have in system.random that could maybe help us here? I think we could probably generate a list of numbers. Generating. Oh. A single value, uniform, random R's. Okay. I think those are the ones, maybe. Roll a variant of random. Okay. Let's make some helper functions for working with our generation state. I'm just going to wrap around that, really. Make it ints. All this is going to do is it's going to get a generator by asking for it from the state, or sorry, gets. And then we're going to call our randoms. But why isn't it returning a new generator? That's what I want to know. Okay, well, let's make it generate one. And we'll get let X be random. Uniform.
But it will be an anecdotal event when compared to something as dramatic as the creation of an artificial intelligence.
Gen.
If human beings are uploaded or augmented, I don't think it's appropriate to call them human anymore. They will be something.
Where'd it go? Peer number interface. Ba. Uniform R seems pretty good. Uniform R. We have to give it a range. We know the fixed size of our thing, so it's inclusive. 0 to 14 is 15 by 15. Put a gen there. We get an X. We're good. We want to put back into our state. And then return X. Oh, right. That's how we do that. Yeah, gen prime. Pow, pow. Okay, so we can generate one random in our state monad. Good, good, good. Which means we should be able to generate more. We can stars X. Traverse over that, doing gen random. Traverse underscore, gen random. No, I meant. I gotta import it, I guess. No, we do want traverse. This function, just gonna ignore its input. It's kind of like sequence. Sort of. But we're only going to demand, we're going to zip. We'll take 15 of those. And we'll take 15 of those. And then we'll zip them together. Like that. So just defaulting some constraints here. Let's see if we can just help traverse out there a little bit. I'll just get rid of that error. So the A is going to be the first thing. So it doesn't know what A is, so it should just be able to go traverse into. Doesn't really matter. Nope, it doesn't want that. Oh, it's going to be F first. Okay, my type application's not working. But the other way we can do this is we can just specify the type of this. We put it in braces, give it a type like that. GHC is GHCI. Oh no, what have you done? There we go. Okay, we're back up to speed. Oh, sorry, I gave the wrong type signature. And okay, it's got to do it twice. Ah, gross. One of those weird situations where I'm just using such high-level things, I can't figure out the types on it. Oh, well, it's not that it can, it just doesn't want to default to anything. It's being very, very explicit. Which is good, generally, but sometimes it leads to us having to specify things. So we don't need... yeah, this could be point free is all it's saying here. Cool. Okay. There's our star generation. Pretty cool. Pretty cool. All right. So enemy ships now. We don't necessarily want... well, oh, here's the other thing. This isn't quite right. If we do every single coordinate a star, we're going to construct our quadrants, our sector inappropriately. So sometimes we want stars, sometimes we don't. We don't necessarily want all 15 of these to be in there. So let's parameterize the 15 there as num stars, and that could be a gen random. That's over 0 to 14. So let's put our own helper function, gen random between. And call bounds. Very similar structure to this. It'll be uniform, except we're going to specify bounds. We're going to just pass it in. Yeah, put a space. Where I need a space. Bang. Alright, how are we doing for time? Not too bad. Ah, shadowed. These... okay. So, we'll say like between 0 and 5. Could be deep space. Okay, so hopefully when we generate the sector stars, that will be appropriate there. So the other thing that's going to be interesting now that we're working on enemy ships, so that we have sector stars, is that we're going to want to start using some kind of way of making sure that we maintain that sector data invariant. Only we have to do it here at the quadrant level. Because the way we get the sector data is we actually we get it from the quadrant data. The quadrant has all of the data for the whole galaxy in it. We get a slice of it to generate a sector. And then we do the thing. So a sector is really just a view of a part of the quadrant data. And I think the way we probably want to be doing this as we're generating these things is using that interface to sectors so that we know that the sector data is right. And then once we know the sector data is fine, we pop that data into the quadrant. Yeah, I think so. I think so. But I like this so far. Let's give it a little shot here. See if we can generate some sector stars. We're going to need to import... oh, what's the... Jeez. Let's import whatever. State, not strict. Exec state. And we'll give it our generations. We need our system random generator, our initial one. Let's create one. Mux.gen. Yeah. Gen, let G equal mux.gen. Some number. Cool, cool, cool. And then we can run state or exec state. And we're going to give it our generation state with G. And we'll try generate quadrant stars. Okay. Yeah. Use the wrong one here. Okay, eval state. Near. Oh no, I can't display it. I think I've lost my a situation here. Okay, so... I think it works, hopefully, maybe? Let's try just the stars one. Generate sector stars. Oh, now Windows is fun. Oh, Windows funness. Okay, keyboard manager, blah, blah, blah. This happens every once in a while. And then this is what I use to flip control caps lock. A couple of other goodies like tiling and stuff, window management and all that. Okay, there we go. We're back. Sector stars. And we'll just do it like 0, 0, say. You don't care. You're just generating an empty list. Because we say 0. So you're generating no stars for us. That's good. That's okay. Let's create a new standard generator. With the seed. So some number of stars, maybe more. Who knows? Okay, so it doesn't want infinite lists. It doesn't like that. Maybe the functor doesn't know that we're demanding only a certain number. So if we do this, and then we can get rid of the take. And maybe this will work. Oh no, we need to generate G again. Bop, bop, bop. That's better. Cool, cool. Seems to be alright. Let's try a different seed. A little bit bigger. Okay. Cool, cool, cool. That's all it was. The functor for some reason was... I don't know. Peak was not demanding it for some reason. When it went through the functor, so... There we go. Now that we know numstars returns an int, I think we can remove that type annotation. At least. No need to get fancy here. Ugly, but not fancy. Sweet. Alright, I like it. But unfortunately, we're out of time for the stream this week, friends. So, that's that. We're making our way through procedural generation. And, yeah, once we get done with that, we will have an awesome game where you will have a whole quadrant stuff to explore. We still have some undefined and stuff, so it's not gonna work yet. So let's just try and get it to compile, and then that's gonna be that. So we can do map.empty. Yeah, that should compile. Hey, Sean Vader, how you doing, bud? Hope you're doing well. Yeah, we're just in the middle of procedural generation now. So, we're getting stars going. I think if this compiles and works, we should be able to zip around the quadrant, check out the different sectors, and see a bunch of random stars in different places. Yeah, things are okay here. Things are pretty good. You missed the earlier. That's the reason why I couldn't stream last week. A friend of mine needed a little bit of help with a housing situation. They found a place to stay, but they couldn't take their cats with them for the moment, so I had to take in a bunch of extra cats until they can find a house, a permanent place. And one of them, they're very curious, jumpy little fellows. They knocked over my camera, and it was a whole thing. Hello, still got an undefined sitting in here. Where did we put it? It's still in quadrant generate. No, it's not. Not anymore. It built, yeah. Oh. Oh. Yeah, we can't do pure.map.empty. So it compiles, but it's not going to run. Let's try and get that going too. We have to put the coordinates in for the quadrant in order to construct it properly. Yeah, we just can't. We can put in empty arrays. So we'll do pure map.fromList. Yeah, this will be chord something from quadrant chords. That kind of thing. What's that something? Is going to be an empty list, an empty array. Yeah, we're gonna need to find that there. We're gonna need. We got data array and scope. Forget how to do it. I'm pretty sure I remember, but I just got stream brain, so I'm gonna look it up. It's list array, but I believe we had to give the bounds as like a negative in order to construct the empty list. Zero, -1, empty list. And we'll do basically the same thing for stations. Pure, pure, totally pure, very pure. We'll just trade enemy for station. Okay. 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 Should go. I think it'll compile. There we go. We're linking. We're good. All right. I think that'll make that go away. There we go. Look at that. Random stars. Let's jump. Let's warp. 1-1. We should see different stars. Excellent. Cool. So yeah, we got random universe generation partially working. We could tweak it as we go and play with it a little bit, but yeah. Let's commit that. Boom, boom. Partial quadrant generation. Thanks. So this is going to be the last stream of the year. 2023 is coming to a close. I've been doing this for nearly 2 years now. Just focusing on almost exclusively on Haskell for the last couple of years. Hopefully it's been a pretty good ride so far. LambdaTrek is coming along. I think next year we will continue on with it a little bit and get it to a good enough point where it's playable. And then we'll see. We'll take a poll, I guess, from the community and see what project we want to do next in the new year. New year, new projects, that kind of thing. We had one from a while ago that we haven't gotten this far with, which was like kind of a graphical text adventure style game engine. We could probably work on a little more, or maybe we could start something new and exciting. Maybe we can start exploring some new Haskell features or do some interesting projects. So let me know. You can always follow me, of course, on the Mastodons in the Fediverse. And I'll show you where the code is for this project. And you can start on GitHub there. If you go to the link above me, there is a link to a Discord server where we can keep in touch. You know, keep in touch over the holidays or whenever. Talk about your projects. If you're watching the stream asynchronously, you're watching my VODs on YouTube, you know, you can chat there as well in between streams. You know, ask any questions you wanted to ask or anything like that. And let's just make sure our commits look good. Yeah, push those up. So all the code for this project, LambdaTrek, is up here. On Agent Ultra on GitHub. I'm Agent Ultra. Been a pleasure. I don't know why it's warning me all that. I have all of that already, but anyway. Types.pl. That's where I am on the Fediverse. So you can follow me there. You can get updates on that. I should be back on the first or second Tuesday of the month. Probably the second Tuesday of the month. In 2024. And we'll have another year of Haskell hacking and stuff. Well, it's been a pleasure. Thanks again for watching. Let's see maybe if we can find someone to raid on the Twitches of the TVs. And I wish you all, wherever you are, a peaceful, happy time, if that's possible. I hope you're safe out there and you're taking care of yourself, or that you will be soon. This world could use a lot more peace and happiness and getting along than it has seen in recent years. Let me tell you. Okay, Strager is up. Strager builds cool stuff, mostly C++ programmer, but he's super smart and a lot of fun to watch. Let's go. Let's get this. Ads, though. Clearly, I don't have my subs up to date here. Sorry, Strager. Let's go. Give him a follow. Give him a like. Bounce in. And have a good new year. Take care, everybody.